Good morning, Grid Connections listeners, and welcome back to Season 6 of Grid Connections, the podcast where we explore all things transportation, clean energy, and our power grid connecting all of these systems together. This season, we are actually upping the ante, and we'll be trying our best to bring you not one, but two new episodes per week, covering more topics and highlighting how all the technologies we discuss here work together. We're excited to share some of the great guests and panels we already have lined up for this season, but please let us know who you want to hear from. Or even if you just have an idea for an episode, please reach out to us either on social channels, our website, gridconnections.fm, or email us at guests@gridconnections.fm. In today's episode, we're joined by Patrick Sherwin, CEO and founder of GoSun, a company bringing a wide array of consumer solar products to market, from ultra-efficient solar ovens to an innovative new EV solar charger that lets you drive on sunshine. Patrick takes us on a fascinating journey, revealing how GoSun started with a wildly successful Kickstarter for a portable solar oven and grew into a powerhouse for delivering consumer solar products. If you've ever wondered how flexible solar panels can handle the abuse of everyday life or how you can unlock true energy independence, this conversation is for you. We dive into the mechanics of EV charging powered by their compact solar panels, why solar manufacturing is booming in China, and the future of making solar power more accessible for everyone. Whether you're an EV enthusiast ready to ditch the gas pump, a weekend camper looking for portable energy solutions, or just curious about sustainable living, you won't want to miss Patrick's insights on how easy and affordable it can be to embrace the solar revolution. If you enjoy this episode, share it with at least one friend or fellow clean tech fan who'd appreciate learning more about solar-powered solutions. And while you're at it, help us spread the word by leaving a positive review on our podcast page. Your feedback helps us reach even more listeners eager to plug into the latest in renewable energy. With that, enjoy. Patrick, thank you for coming on today. And for anyone that's not familiar, let's kind of get into this and kind of learn more about your background and how this all began.
Wow, what a pleasure, Chase. Thanks for the intro. Yeah, we're definitely in similar streams here. I have been working with solar for about 25 years, trying to figure out how to get it to power our lives and enter the electric vehicle. What a fun opportunity to combine the two. My focus has been in kind of independence and resilience. I was on the solar coaster for many years doing commercial installs, doing design work, running up and down rooftops, both residential and commercial, and, getting into something smaller scale with GoSun, launched it on a Kickstarter about a decade ago to develop like consumer-based solar-powered appliances for recreation and resilience. And that has entered a whole new career and kind of my path as both entrepreneur and inventor. And it's just been a ton of fun coming up with solutions to kind of everyday life, as well as some of these bigger challenges that face our world and face EV ownership. And so I'm stoked to be here. Thanks so much for having me.
Yeah, no, I think it's great. And I mean, right even before we started recording, Patrick, we were kind of talking about how we both have been involved with electric vehicles and commercial solar. And it's just wild to see how, as I kind of refer to it, used to be kind of like the homebrew thing or something you would see that someone had in their garage somewhere. And it was such a foreign concept when an electric vehicle or even having solar on your roof is. And it's like most people probably know solar as far, not that long ago, as being solar powered calculator or what was used for satellites or something. Otherwise, it seemed like a foreign, too expensive concept. And I've always been fascinated with just, and I mean, to be honest with you, that's almost kind of the nexus of this podcast, was like the connection between solar and renewable energy in general, but especially like solar and electric vehicles and the role the grid can play. And one of the things I've always just thought is so interesting, and I try not to get really into politics on this side, but it's just like, I've never quite understood why people wouldn't be. I understand if you don't want to have it or whatever, but I think I've never fully understood why people are against it in a lot of ways, where it just enables you to kind of have that independence. I can kind of get the HOA aesthetic argument. That's its own podcast. We won't talk about that today. But I mean, especially if you have like the space to do it or the roof space to do it, it just enables so many cool things to really allow for resiliency and energy independence. And I guess my background's blurred right now, but we're actually having a pretty decent snowstorm move in. And so like having that kind of energy backup and stuff is nice. And I know a lot of people think, well, it's snowing. Doesn't that mean your solar panels don't work? And I think that's what's kind of so crazy and wild about them is actually, no, it still will. It won't probably produce as much. But then the instant, if the sun comes out and it's cold out, then you do see the efficiency go way up. So it's like, I don't know. Obviously, you and I could kind of nerd out on this and go way down these kind of rabbit holes. But it's just really cool to see what you're doing and across so many things. And we'll obviously get into the EV product right now. But I guess to take a step back, you mentioned a Kickstarter. That used to be, I feel like, such the craze and everyone was doing those. Now you don't see those as much anymore. And I think it was such a great thing for business like yours to actually be a way to kind of launch and start building new products. But yeah, let's kind of just start there and just kind of learn about what led to that and how that kind of kicked off and how it's kind of developed now into a lot of other products.
Cool. Yeah, I think we're looking at a new era where if you go back to like our parents' lives, and they were hot rodding, right? They were taking stock vehicles and making them much higher performing, and doing creative things in their garages. I know my father was a muscle man, muscle head, muscle car driver, and always tweaking and tuning up his vets. That same thing's kind of happening in our generation, but in more of this, what I would consider this renewable energy advent, like people that are innovative, kind of artistic, nerdy, they're tinkering in their garages on electric cars, on solar systems, battery systems. And they're, we're kind of quietly ushering in a new era. Maybe it's not as vain or in front of everyone. It's not as cool as the hot rod era, but it kind of ties in what you were sharing. Like, it's surprising to me that more people aren't doing it. I've always been a tinkerer. I've always wanted to come up with solutions. I've always seen kind of the shortcomings of the fossil fuel dominated paradigm that we're in, the shortcomings of pollution. When I was a kid, I watched somebody dump a bunch of oil into our neighborhood creek. I had the creek, thriving with fish and amphibians, and that oil spill, one single car change of oil, like about 5 liters, destroyed everything in the creek for the whole summer. And that just kind of turned me into more of a problem solver. You don't have to call it an environmentalist, but it just a charge to kind of get away from the mess of utilizing this dark fuel. And it's like, we don't really have to make fire. We can drive silently. We can drive on sunshine, on electric power. And that's kind of been the thrust for a lot of my career. The first thing that I launched on Kickstarter was a solar powered oven that makes a meal in 20 minutes with nothing but sunlight. And that was based on an evacuated tube solar thermal, like a water heating device that was developed in the 1980s. And I just repurposed it for cooking. And I'd done a lot with other solar ovens. They were super slow and bulky. And all of a sudden, here's one that really works, and works even on these days like you're talking about, even when it's like overcast or partly cloudy. It's not going to work at night. It's not going to work when it's buried by 3 feet of snow, but it'll work in the freezing cold winter. It loves those bluebird sunny days. And we kind of rocked the solar cooking industry, which is not saying much because it's the tiniest industry in the world. You cannot find a smaller industry.
Yeah, and I for those listening, I'm kind of sharing the screen right now, but I was able to pull up one of the items, exactly that, the solar oven. And it is such an interesting thing because obviously this is a very modern design of it, and it's pretty cool how this works. But like the fundamentals of this is so well because it's been around for so long. Like a lot of Native American and other kind of people used to use essentially solar heat and other kind of reflective ways to cook and do stuff like that. And this design that you guys came up with, it looks like you have quite a few, so I'm not sure which is probably the most popular these days or the primary one, but it is just kind of a cool option to have for cooking, and just it's nice that it's also pretty looks pretty portable. So for like camping and those kinds of things, it's a great option alternative.
Yeah, thanks. And that vacuum insulation really is a game changer. For I guess a lot of the dominant culture thinks that solar doesn't work. That the solar that was installed in the 1970s just sunburned our parents, and then it got a little bit cheaper in the 80s and 90s and 2000s, but it was still out of reach and too expensive. And that has changed dramatically in the last decade. So I encourage listeners to take another look at the cost of solar, and that's obviously a big part of my career, or my interest is to mainstream solar and make it as accessible as possible. And these ovens are a fantastic way to do that, a way to prove how powerful and capable the sun is at powering our daily lives. So I, so we've sold a ton of these solar ovens, but again, we may have taken over, 30, 40, 50% market share of solar ovens
Oh,
globally,
wow.
but that's that. You may not have industry tycoons on your show every day, but you're looking at one here. but the solar oven industry is $3 million, million, not billion, annually. So across the entire globe. So we had to pivot and do more. And being a tinkerer, a problem solver, an inventor, there's the sky's the limit. So we got into like solar powered refrigeration, water purification and sanitation. We've just done a ton of different appliances where we see opportunities. And we've been very nimble and sort of very quick and effective to take an idea and move it into production. And we often lean on crowdfunding, even to this day, where we'll take an idea, we'll kind of share it with our audience on the internet, on social medias, and we'll see the response. Are people interested in this? Is this something that could go somewhere? Do they think it's worth $500, $300, $2,000? And with their vote, there's then we decide to what extent are we going to be investing in the engineering, production, design, tooling, testing, refinement of that particular product solution. We've done that about 20 times in the last decade. It's been a really a great, thrilling ride to kind of have a short feedback loop between us and our customer base, so they kind of like develop our products with us.
Yeah, and I think it's really cool. Like I said, I came across, and we'll get to this, the solar photovoltaic side, but that I think is one of the things that aren't fully appreciated. That solar can be used in many different ways. You can use it as an indirect or direct light source. You can use it obviously for the way you do, where there's really not even a photovoltaic. It's really just refocusing the energy itself into cooking something. And then obviously, I think probably the more common and what probably most people think about when they think solar is kind of solar photovoltaic. And I guess once again, this goes to me just being a nerd about this space. I just think it's so wildly fantastic and wild that this essentially something that's millions of miles away and it's only like a fraction of it is hitting the earth can be used not only in so many ways, but essentially like every form of fuel or power type is either solar or more or less indirect solar through a bunch of different processes. And so I think it's really great just to kind of have these things. And I think there has been a little bit, there's the consumer side where it's like, okay, the photovoltaics on my house, maybe that's too expensive. But especially kind of like in the backpacking or people who like to go hiking, there's become a lot more things that like you guys offer, but things that kind of start seeing like, okay, that you can use solar in your day-to-day life. Sure, maybe it's not going to power your entire house, whether that be for financial reasons or just maybe your house is shaded or something. But it is really cool to see a lot of these things that this starts to unlock and really does provide to people in different ways that I don't think many people fully appreciate until recently.
Yeah. I remember about 3 decades ago when I was really starting to get serious in my tinkering and approach to the world. My older sister, who works for General Electric, she said, electricity's not going to go anywhere, Patrick. You don't, you're not going to reinvent something that's better than that anytime soon. So you might as well try to stay in that lane. And look at us now,
Right.
3 decades later, and like that's just like more true than ever. I mean, everyone's trying to figure out electric flight, and just what we can do with electrons, and of course zeros and ones, but what we can do is phenomenal, and it's so much easier than a liquid fuel. It's so much better than liquid fuel that comes from far away. And you can make it
Yeah.
right there in your backyard. Uh, modern solar panels are almost all now over 20% efficient, which is
Right.
it's mind blowing. And you really don't need that much of it to power the bulk of our modern life. And then with the cost of energy storage continually dropping, it's really again, the opportunities are phenomenal, and it's kind of the powers that be that are the only thing really in the way. A lot of it's improper leadership and bias, and people kind of holding on to the past, holding on to the way that they know how to entrench and control and maintain the money flow in their pockets. And so it's kind of a shame that more people don't see it as electric vehicles and solar as the path for the future and for independence and autonomy, and to be more secure and more resilient. We don't have to go into someone else's desert and deal with refinement. That's what always kind of makes me laugh. They're not going to take away my trucks. I'm never going electric. It's like, hold on, buddy. Let me just ask you, like, do you own an oil well, or a refinery, or a pipeline, or freighters, or like, where are you getting your freedom and your independence from the corner gas station? That, like, you're super dependent. You're more dependent than somebody driving on sunshine. So I don't quite get it. It has to do, so it's so culturally nuanced, right? That the solar guys have always been the weenies that don't know what they're doing, and again, that's changing.
For sure.
I mean, it changes every day. I push my gas pedal after a stoplight in my electric car. You just blow everybody's doors off, and it's slowly changing. But it is kind of sad and surprising to me that more people don't see this as a path for opportunity and freedom, and job creation and economic growth and all those things that are critical to our future. And rather, we're giving a lot of that away to China, who does see this opportunity and does have the predicament of not as much natural resources. So they are thrusting their entire industrial machine into solar and wind and energy storage, because they have to a bit more than we do.
For sure. And I think that is kind of one of the, I guess, caveats some would say with solar is just like so much now is produced, unfortunately, in China and stuff. And we used to have a fairly decent solar manufacturing base here, but partially due to costs and partially due to incentives. And it's one of those things that I would love to see when you talk about domestic manufacturing. I think obviously China has a place to play in it globally, but it is one of the things I'd love to see is just more of that domestically made. And I think maybe some of that has to do with that story. But overall, you're totally right. I'll be the first to admit, like, gas is an incredibly dense liquid fuel source. But what's really interesting is, like, how do you put that energy to work? And of course, a lot of it is given off in either light or heat energy. And then you only have X amount released after that can be put to work, yada, 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 yada. And that's what's so fascinating too, with like the battery component to this, is like that kind of has been the missing piece. And while we've had battery technology, there's been a pretty healthy century of science and engineering that's gone into making combustion engines and using that fuel source as effectively as possible. I mean, trillions of dollars have gone into that. And so it's really cool to see how much progress has already been made, really even in the last decade, and just shows how much opportunity and kind of hope there is to further increase the energy density of it. And once again, you just don't need as much energy in a battery source because you're able to use that energy so much more efficiently, because it's not being, I mean, technically a little bit's like going to heat, but it's like on a 1% versus 30% basis, and those kinds of things here and there that really helps drive that direct relation to what you're putting in and getting out of it. So obviously I'm talking to the choir here, probably between our listeners and yourself, Patrick, as far as how that all works and what the potential is there for. But I guess I am curious. I know with your company, you guys are primarily based here, and then is a lot of the manufacturing overseas, or is it kind of a mix of both?
a little mixed, but by and large, the evacuated tube from our original product launch on the solar ovens was manufactured in China. It was originally manufactured in the States, Australia, Germany, and
Oh,
then China has really kind of dominated that in the 1990s, 2000s. And no, I literally couldn't find any manufacturers outside of China when we first started.
really? Wow.
And then when it comes to a lot of the other elements that we integrate into our tech, photovoltaics, lithium ion, printed circuit boards, and just plastics and
Yeah.
silicone, and you name the part. The Chinese supply chain is so robust that I've done a lot of exercises to consider domestic manufacturing, and they almost always end with 3x the price and the timelines are way
Yeah.
longer in the States. So I do hope that that changes. I don't see that changing anytime soon, despite all of the efforts and the blowhard around tariffs. China is an absolute juggernaut in the world supply chain, and I don't really see currently that I have any viable options for a lot of the stuff that I manufacture. So we'll kind of come up with the prototype. We'll domestically source a number of things to get everything working and aligning, and then we'll go to China. And we own a facility in Ningbo near Shanghai where we can kind of control things related to intellectual property or quality control and assurance. So we've had a really great relationship that's over a decade long now that's really paid off. And the tariffs and all that are really going to hurt. They're going to hurt our business, and it's going to hurt the American consumer. I don't disagree. You got to give your competition some challenge,
Yeah.
but it's a new era, an interesting era, and it's definitely an added risk or threat to many businesses. And it's almost laughable to think that we're going to be reshoring, American jobs on so many things. Like, Americans don't want those kinds of jobs, and we're not, we're so far past building the bulk of our consumer goods. We're just that ship has sailed. Uh, so so
Yeah, it's an
uh,
interesting kind of dilemma because yeah, I do agree with you, and I mean I've done my own sourcing for stuff, and it is just one of those things where it's like, yeah, I would love to hire it out or do things like that, but I've been in that same boat where it's like the costs are so much more, and sometimes you have quality issues and the timeline. And to be honest with you, it's like, yeah, the two big things, especially like solar manufacturing and like battery production, we're starting to see maybe the latter do a little bit here, but it's still just like peanuts. I mean, it's just like nothing compared to like the manufacturing base that China right has. And I agree with that. I'd love to see that change. It's not going to happen overnight. Because I do think in the end, it actually kind of does help the consumer globally, just having the different options. But it's one of those things that is still pretty far behind. And I mean, and it's been interesting to me too, because I've even worked with a couple of companies around like doing EV, essentially speaking of kind of like the traditional muscle cars and kind of tricking those out. Obviously, we've kind of had the change from mechanical engineering to like more electrical engineering. And now you do have like a lot of traditional classic cars that are being converted to electric. And some of them are essentially getting around some of the traditional battery tariffs by essentially just ordering cells, and then yeah, they put it together to make the battery, but like the actual like domestically, but it's like the main actual products and the hard costs in some ways are still, and it's just one of those things that I hope to see change. But I agree with you. It's like there's a large headwind, and there's some of it's reality, some of it is legitimate concern around even environmental concerns around some of the manufacturing and other stuff like that. But with that, unfortunate reality. But I agree with it. I think we're kind of in the same place. Like we'd love to see it change. And the fact is, just even through my own experience, I'm not expecting that. It doesn't matter who's in to see that happen as soon as I'd like, whether that be emotionally or realistically. So pivoting a bit though. So obviously you start with the solar heater, then you start kind of expanding into some of these other products, and then this is what I came across your company with first. Is let's see, I'll share the screen real quick. The and I've actually now seen quite a few ads for this. the EV solar charger. So it's essentially, for those listening, it kind of looks like it. If you were driving down the road, it almost looked like it's a Model 3 or Model Y with a normal Thule box, or kind of something that people put. It's a thin one, but it looks like you'd put skis or something in. Well, what you do is you unzip it, open it up, and then flips out about let's see, seven, or I guess about 8 or 9 solar panels to cover the car. To then you can use that to charge the car during the day. Now, it's obviously not going to be the same as like having a level 2 charger at home, but it really does start to unlock some really cool things, especially if you go camping, or like if you park and live on the street and you don't have really a reliable place to charge. As long as you can park in an area that's halfway well lit during the day, it has a lot of cool benefits. But Patrick, why don't I'll let you talk about it, and kind of the uh, what kind of caused it to happen, and what made you kind of start this whole project? Because I'm really curious, like between what led to its creation, and then like the actual engineering and some of the things you've come across along the way, and just the whole process.
Awesome. Yeah, great intro to the GoSun EV solar charger. It's been an odyssey to drive on sunshine. Just probably the most efficient form of transport that we could come outside of a bicycle. But I started a company down in Asheville, North Carolina, about 20 years ago, to take a bike shop and convert most of our bikes into neighborhood electric vehicles, and then solarized charging stations. And we were a little ahead of the curve. And stationary solar charging has become, very popular. It's kind of carports covered in solar, and it's a phenomenal combination of technologies there. Um, and then with GoSun, we focused a lot more on these smaller consumer products for many years. We're still in the consumer direct-to-consumer space, basically wanting to sell products that can ship to your door using the internet. And we started to explore the idea of, what would it take to solar charge your car using available flexible solar technology that's nearly as long lasting and durable as the traditional framed photovoltaics, and also now on a cost parity of traditional solar, but obviously much lighter and safer and easier to dispatch in different mechanisms, different ways. So we looked at all kinds of different ways to dispatch it. We looked at sliding drawers and various accordion style folding origamis. You can keep scrolling down the page and you'll see a few more applications of the product on different vehicles and whatnot. And basically we realized we can get 1,100 watts into this little 4x4 foot, by 5 inch tall, rooftop carrying case. And everything, all of the technology needed to charge your car is up in that case as well. So you just literally, as the picture is shown on the screen, you just literally open up the case, dispatch the solar cells across the body of the vehicle, and pull your EVSE cable out and plug it in. And as your car is sitting in the sun all day while you're at work or wherever you are camping or whatever, you are charging on sunshine via level 1, just 110 volt. We would love to be able to go directly to the car's battery, but that's going to be years before we have good relations with EV manufacturers. In order to do that, it would certainly be more efficient because solar is DC and the car battery is obviously DC. Instead, we run the solar energy. Each panel is connected in parallel. So if one of them is shaded, it's no big deal. Or if the angles are different, they all contribute to a central 1,500 watt lithium iron phosphate battery. That battery is then integrated with a inverter that has a series of smarts that can kind of act. The battery can act like a pass through, so the energy is just getting directly inverted to be dispatched to the car. So in many situations that'll be the case. Like when you have good full sun, you'll be making 1,100 watts and you'll be sending that straight into the car. And then, there's a 200-watt stationary panel on the top that's always charging that onboard battery. And that onboard battery is, we're calling kind of like a buffer battery, that it essentially kind of absorbs this varying power source to then give your car a more consistent source and dispatch it at a consistent rate to the car. Most electric vehicles don't want to be charged anything more than about 6 or 7 amps at level 110 volt. So we have to make sure we're dispatching at least that. And so in summary, you can get upwards, in the best case scenario, you can get 30 miles of range in a day. On average, you'll probably be getting sun-teen miles. So, somewhere between, on a gray day, 10 miles, on a sunny day, 20 miles. And it turns out that the average electric vehicle owner drives about 17 miles a day. So, we know that we're not going to be making that every single day, but we think we're easily able to meet 50% of that, on an annual basis in many, many places across the country.
Yeah,
In some places, some situations, it could be 100% of your driving needs.
well, and there's two really interesting things that come about with this. Is one, yeah, you're right. Like, is it obviously the same as going to like a DC fast charger? I think that's something we talk a lot about on this channel. No. Is that what most people need today? Actually not. And the second thing that I think is actually really cool about this is that it's cool, literally, in that the fact that because you're covering, at least in this case of like the Model 3 and others that, and a lot of EVs now do have glass roofs, which are, they definitely make the car feel more open, kind of give you more space. The downside is you do kind of get sometimes that greenhouse effect. Whereas now with this, you're actually keeping the car itself cooler, so you don't have to worry about like AC or other things kind of shutting on, especially not, or turning on, especially in a hot day. And then you're also, yeah, using that solar energy to then slowly kind of trickle charge the battery. That I think for a lot of people, especially those who are like in multifamily or have to park on the street, this makes a lot of sense for kind of like avoiding, and makes kind of EVs a lot more practical than having to go like charge once or twice a week at a local charging spot. And I'm kind of curious. One of the things I guess in full disclosure, I actually did put down, I don't know, I guess I haven't even told you, I put $100 down like a few months ago. Because when I first saw this, I saw like that 3D version of the Tesla one. I was like, oh, okay, this isn't going to go anywhere. And then I saw a couple of these photos like, oh, they've actually put it on a real car. Okay, so they're at least past most of these things you'll see online. They're at least trying to prototype. And I was like, you know what, $100, why not? I think I'm in a pretty fortunate position that we can pretty much charge at home anyway. But I just think it's a really cool product and a really cool application, because so many people over the years, when I've talked about EVs, are asked like, well, why don't you just make one of those, like the window a solar panel? Or what if you put a solar panel on? And just the fact of the matter is, even if you had a 100% efficient solar panel just like on that roof section, you're barely going to be able to like make a whole lot of energy. But if you can increase that surface area like this does, then you're not making a whole lot of energy, but you're making enough that it really is justifiable and really does help with the experience. And like I said, it also just has the advantage of cooling down the car during the day too, especially on hot days, which I think is a really great advantage and good design. One question I have for you though is, I have seen, and like other engineers and other people try to like mock up ways. And so one way they do this, I think this is actually probably the most resilient and like streamlined and clean design. The one I have seen other people do is where they literally put like 12 solar panels together, and it'll like go out in two directions. And I think price wise and other things, and just engineering wise and weight wise, you start running into a lot of weird issues. But I'm kind of curious, like, is that why you chose this design, or kind of what are some of maybe the variables? Obviously, trying to get as much sun as you can is a big one, but like, what were some of the trade-offs kind of going through this design process that had your team end up with this design overall?
Yeah, awesome. Great question, Chase. And thank you so much for your backing, your support. We do have a reservation funnel for the EV solar charger, $100, and then we're gonna be delivering this summer. So
Cool.
I think the important thing, from a sales perspective here, if I could put my sales hat on, it is that GoSun always delivers. We have had, as I mentioned, I think 15 products that we've launched via Kickstarter and Indiegogo, and we have tens of thousands of customers that we've made happy with with our newfangled ideas, and we've always delivered, and we've always made sure that what we deliver performs and is protected and insured, and you get your warranty with us. um, we so we want to make sure that this thing works and works for the long haul. So I think that is the main answer to the question you had asked. Like, we certainly looked at like the sliding drawer concepts. We did an exhaustive exploration
I'm
on the
sure.
concept phase, and with you know the mechanisms costing a bunch, you know the, the challenge of fitting things in such a small space. We and really what changed our approach the most is that flexible solar panels have there's a new technology that's basically unbreakable. The translation is anti-crack. I believe this
Hmm.
was a technology that was developed in China with these flexible panels. They are now able to withstand the abuses of pressure and torsion and compression, and of course wind's gonna make things furl, and then you have the consumer that does something stupid and drops it. These panels are able to handle all of that, and so that really helped us inform our process and say, we can save the consumer a whole bunch of headache and save us a bunch of really near impossible mechanical design exercises, and just allow them to lay this across the body of the vehicle, or lay it across anything, anywhere. Like, it doesn't have to go on a car. Um, and it still gets its job done, and you don't have to treat it real nicely and perfectly, and you don't have to be a highly trained engineer to get it to slide in and out. And then what happens when the mechanism gets grimy and doesn't want to work anymore, and you start forcing it closed and it pops because it's made out of thin carbon fiber. And I mean, we looked at it. I'm sure this whole concept is going to get a lot more invention and iteration over time. But I think the beauty here is that flexible solar has made its way. I've got a prototype on my vehicle, a working prototype on my Tesla Y, and it is doing its job every day, all day, and I don't see any degradation or any point where it's going to, I'm hoping to get a decade out of this first prototype. And that's how I use things. I'm not nice on them. My whole job is to break them. And, and so that's kind of why we led into this. You might want to call it a little bit more simple of a mode. Like, it's definitely version 1.0. The other thing about it, and the way we wanted to approach the design, is we really wanted to make the job on the consumer easier from an electronic standpoint. So we basically packed like a power bank. We took what's a typical, small cooler or a toaster oven looking thing, and we made it flat and wide,
Yeah.
um, and and stuffed it in the box so that you don't have wires going in and out of the vehicle, and you don't want your electronics in the car. They're going to overheat. So you want
Right.
them somewhere where they can hurry up and exhaust, because inevitably you're going to be making heat here. Things aren't perfectly efficient. And so those were kind of the big design things. And then the cost of the thermoform, this big rooftop carrier case. I originally, when I started down this path, I said, "There's no way we're going to make one of those. That's going to cost like $50,000 in tooling." But I was wrong,
Right.
and in fact, it's not a horribly prohibitive. We've already built a couple tools because we're going through the iterations of getting our design just right. And the final tooling for something like that is really not, it's not super exacting. The tooling can be made out of aluminum instead of tool steel, and those are the kind of factors that also play in. So our effort is durability, performance, and cost. We want it to be low cost and accessible. We want to be able to ship it to your door as well. So those are all big factors, because we have the direct to consumer thing down, and we don't want to deviate and have to ship it via freight or have to
Right.
force people to finance it. Those kinds of issues.
Well, I think you actually had a lot of great points. One, yeah, you're right. Actually, to really go back to, I think part of the reason I also felt comfortable wasn't 100%. It was one, you had the mock-up, and then two, you actually had a real one. But then three, when I actually started looking into it, I was like, oh, this company's actually built other stuff. So like, I felt a lot more comfortable putting down $100 versus like a normal Kickstarter kind of thing. But yeah, I'm really interested in trying to share the screen again, but having some issues here. Uh, I'm just kind of curious, like when you're going through this, because it looks like in the mock-up, it shows it's got the normal like Tesla charge plug. Is that what you're kind of expecting this maybe version 1.0 to ship with, or will there be a few different versions if you have like a J1772 to speak the EV parlance? But then I also see this kind of mock-up Ford Transit Sprinter van. I was just kind of curious of what like you're seeing as options or how this kind of works when this is
Yeah.
delivered.
Yeah, I know there's not an overabundance of detail on the website yet. We will be revamping that. This is like kind of a reservation funnel at the
Yeah.
moment, and then we're going to work into like the proper pre-sale where it's like this is exactly what you're buying, and kind of more on the detail side of how it works. What we've resolved is that we're literally providing a 110 volt outlet. That's the main thing. There's going to be other sources of power. And then you, the consumer, by and large, you already have an EVSE cable that runs on 110 volt. Typically, it came with the car, free with the purchase of the car, and that's going to have your 110 volt plug. So we're now going to let you use your EVSE cable. If you don't have one, we can help you get one. But our main output is just 110 volt,
Gotcha.
and you can store your EVSE cable up inside the box.
Oh,
So when
okay,
you open the
gotcha.
box, pull, yeah,
That's a good
and
point.
obviously you can't charge your car when you're going about, when you're
Right.
driving. So it's you're going to have to open that and get the solar out, and that's when you pull your EVSE cable out. It's already plugged in. You turn the inverter on, for example. It's also going to have an app, so you can control it from a few hundred feet away, and
Oh, cool.
um, and then it puts out. In that case, level one is typically J1772, so it's the most universal protocol for every EV. Um, but us just by providing 110 volt, we don't really have to get into the
Yeah.
cords.
No,
Um,
that's a good point.
we yeah
And you're kind of right.
yeah
It if you're able to kind of put the EVSE up there and there isn't a cooling issue, which there probably wouldn't be, especially when you're dealing with only level one. Yeah, that kind of makes sense. It's kind of out of the way. It's probably secure. Is there a way you can lock it or something? Or I'm sure
yep
you guys have thought all this.
yep we that's probably been the biggest pushback.
Yeah.
And I'm in a pretty safe place. You probably are too. Cincinnati does not have a whole lot of theft pressure, but people out in San Francisco, Portland, Seattle,
Yeah.
LA, I mean, in New York, they're like, theft, what are you going to do? What are you going to do? And so we, of course, have like multiple mechanisms for preventing theft, including basically an Apple AirTag where,
Oh, cool.
it's
Gotcha.
buried somewhere they can't find it. If it does get stolen, you can alert the authorities and track it. Um, solar by and large has not been subject to too much theft. People don't really understand solar very well or know its value. And maybe
Yeah.
that goes back to the beginning of our conversation. And also, it's not an easy thing to steel in that it's kind of bulky. Solar in
Right.
general is kind of a lot of surface area heavy parts. You often have it installed by a commercial installer, and they've got pretty heavy duty tools. No doubt that somebody could take this if they had the right, angle grinders and they wanted to really get at
They
it.
really have to commit
But
to
that,
it, and you really have to just ditch your car if you're going to let that happen, I guess. If someone's coming to
yeah,
your car with an
right.
angle grinder, then you're in a really bad part of town. But no,
And they
it
may
is
want to
kind
go ahead and just take the whole car
of right.
at
Yeah,
that point.
exactly. No, that's a great point. Because yeah, you're right. That was one of the because I was thinking about when I was looking at this is like I went on a road trip to meet a friend of mine who now lives in the Midwest, and he unfortunately doesn't live in quite the safest area. And I was getting all sorts of not since nothing went wrong. I will say they were fun and entertaining Sentry mode kind of recordings, but in the moment and like right after, I was like, holy crap! There was some sort of there was a gentleman going through some sort of thing that was checking out the. I mean, he was clearly looking through the car, and he had like a 2 foot steel pipe with him. And fortunately, I made sure to leave nothing in the car, and so he didn't break into it. But I guess I would be curious, just as someone who is a really big fan of Sentry mode, is there any way that you can? Because I mean, obviously you do have the side cameras, which probably would be enough. But is there any way for like the front camera to not be blocked or anything? Like, has that kind of been worked into the design at all? I guess, and I realize that may be kind of like that's really just a Tesla or maybe even Rivian specific issue, but I'm just curious about that.
Yeah, it seems it's specific to each vehicle, and I think
Yeah,
that's another thing that we're really trying to go for is a universal
yeah,
fit. So, like that conversation came up a lot with the EVSE. It's like, well, are you using NACS or
right. That's a good point.
and thankfully NACS is now a standard across the country, but it certainly wasn't looking back. So you got 10, 20 years of electric vehicles on the road, and they're not all standardized. Yeah, we're trying to make this thing easy to rack on any. And on any, essentially, you do need a set of crossbars on your vehicle, but we want it to be like universally capable of crossbars on a Rivian, on a
Yeah.
Volvo, on a Tesla. And turns out the Tesla Model Y crossbars are super wide, and it'll still work. And that's almost the threshold. I think they're like 3 feet wide. Typically, crossbars are closer to 2 feet, from center to center. But there is a little bit of room in between panels where you could consider a hole. There's gonna be plenty more learning here, and I love
Yeah.
the
Yeah.
feedback, Chase. I loved all the feedback we got about theft. I mean, this is not. Again, this is version one. We see a whole future in this. I was formerly in the solar carport world, and that world has really blown up. Of course, solar industry by and large has completely exploded, a lot like the EV industries, and this is such a cool blend of the two, and no doubt that this is just step one. We now, like for example, with our solar cooking devices, we now have 5 different ovens in the market, and our first oven is doing fine, and we've made improvements to it. But the ovens that precede that, or sorry, that follow that, are really doing even better. Because of course we learn things, we make them better, we make them faster, bigger, more efficient, all of that kind of stuff.
So we should expect a 40 panel one for the Cybertruck and Rivians. Is that what you're trying to say?
That's right. And it's going to turn into a tent
Yeah.
that
Yeah.
you
Well,
can,
yeah. There you go.
you can
That's a good escalate.
shelter.
I guess I think that totally makes sense. I really appreciate the transparency on that. One other question, I guess, is: are you? I would imagine probably not, but would you be able? Let's say you do have, because a lot of people now do have solar panels for like camping or going off grid. Would you be able to plug those in parallel as well, or something with that, and then it goes into that battery, or is that kind of just trying to do too much?
No, you can.
Oh, really?
And you can do the same like with our solar panels. So you can take our solar panels and plug them into some other battery that you already own
Oh,
from
cool.
EcoFlow or Jackery or Blue Eddy or something. So we try to maximize universality, if that is such a word. And, we definitely encourage people to sort of hack or, whatever, make our technology work for them. And so I don't remember off the top of my head like all what's the full range of our DC input is, but it's surprising what you can do now. Essentially, like if you can dream of it, you can build it. Back like 20 years ago when I was doing this kind of thing, it was super limiting and super expensive, and
Yeah.
everything was so massive. But nowadays, it's like you can stuff it all in this little suitcase, and it can take all kinds of different voltages and inputs and variabilities, and still get that energy into the battery, and the battery's got all the safety integrated with the BMS. I mean, it's literally like I said, like if you can dream it, you can build it. It often depends on your budget, but we're fortunate here. We've had over, I think we have like 1,800 reservations,
Oh,
which is
wow.
bigger than any reservation funnel we've ever created. And essentially,
Cool.
that means that like we're taking our time to get this right. We're building this thing with our very best quality in components, and that way everyone's delighted, and in 10 years they're like, yeah, I got version 1.0 of that thing. Oh, okay, you got the newfangled unit with the tent and the integrated coffee maker. Well, I love my old school one that just charges my car.
Right. Yeah, actually, I guess one other kind of question around that is, I think to take a step back, like what you said is so true and fascinating about solar cells and like how having ones that are very resilient and don't break easily is such a game changer and such a big thing. Because I don't think people fully appreciate when they see solar panels and all this stuff. Like, yeah, they're super heavy, they're all these things. That's because the panel has to be so strong to protect the actual solar cells themselves, traditionally because they're so delicate. The actual cells themselves are super light. And so like actually having, with kind of the rise of thin film and other kind of evolutionary solar technologies that really help make this possible, it's really cool to see that, yeah, now we're starting to finally get some really strong ones that can kind of take a beating and are perfect for this kind of application. So I guess with these ones, are they like and maybe this is kind of getting a little too nerdy for some listeners, but is this a multi-junction type of cell, or is it just really a super resilient kind of traditional monocrystalline? I'm kind of curious of like what the actual cell is, if it's more like a thin film or a little bit of everything.
It is monocrystalline,
It is. Okay,
and
interesting.
no, just a single junction. Um, like I said, I'm not even sure where this got developed, and every other manufacturer is going to claim that they
Yeah,
developed it,
yeah, yeah.
and because this just happened in the last like 2 years or something. Um, but I was in China back in December, and I had to know. Like my brain is just like, you have to show me this. I don't believe you, type of thing. And so I went to several manufacturers, and one that we're really happy with. I spent like 2 days with them, like just going through it over and over and trying to understand the way they're building these. But they literally have 11 layers of material, much of which is ETFE, in this like sandwich composite that they put it in their thermal laminator,
Hmm.
and it enables what in the base layer is this monocrystalline standard cell that's super thin. It's essentially a wafer, and it enables it to move, um, while maintaining strength. So there's it's not that it's like a sheet so that it just can
Yeah.
flap in the wind. Um, and I know that like there's some thin film tech that is kind of hoping to do that, to be like super flexible. You can roll it up into a tiny little.
Right.
But in this case, it has integrity, it has structure. Like it.
It's not so much that it's flexible, it's just that it can do very well being flexed or being abused. that kind of the
And
traditional cells really kind of did struggle with.
and the whole issue with the traditional cell, especially the flexible, is that they'll they'll not only will the cell just crack because it got stressed with a torsion,
Yeah.
it'll also get into micro cracks. So where over time the production will fall off, and and this technology is not prone to micro cracking either. So that's what's so interesting and compelling here. Now, is it going to last as long as a framed solar panel? No. Like a framed panel, solar. The other cool thing about solar people don't realize is that it lasts for 30 years. I mean, I have literally worked on solar projects that are still cranking, that are like almost as old as I am, and I am ancient. And they're over 40 years old, 40-year-old solar stuff I've seen in the field from the early 1980s.
Well, I think that is what's so cool about the technologies. I mean, that's what most of them are warranted for. But and sure, there'll be a little bit of degradation, but and to some way, it's very similar to like lithium-ion battery chemistries that it just degrades a little bit, but it keeps going. And I mean, but you're totally right. I forget like what the solar cell is, but there's one that's like I think almost 100 years old or over that in Dow Labs or something somewhere that had like one of the first
Yeah.
ones, and it just keeps going. Um,
Yeah, no moving parts,
yeah, yeah,
so
exactly.
that's the beauty of it. Moving parts will find a way out. Water will always find a way out of that pipe.
Right.
Where in this case, it's just electrons moving through a circuit. And so, if the
And
thing
pretty low
doesn't last 30
voltages,
years,
yeah.
we're trying, we're definitely shooting for a decade. I believe that these are going to last longer. I don't know if anybody really knows currently with this new technology how specifically durable it is in the long haul. We do know different maintenance protocol, in terms of keeping things clean and dry and that kind of stuff. But we've got flexible solar tech out here that we've had out in the blistering sun and ice and wind and snow and dirt for a long time doing our tests, and things are still putting out solid power. So
Right.
and this is a unique one in that you're going to have kind of a relationship with it. You're going to be packing it up at night. Oftentimes, I mean, there might be times where you leave it out and you park it at the airport and you want your car to charge over the course of a week or two, and you can do that. And what's also cool is that if you want to do that and you're afraid of some kind of a blow up windstorm or some big thunder shower, you can strap it down to your wheel well
Yeah,
as
I was
well.
going to
So
ask you if it's got like any magnets or anything in it, or if it's purely just more or less gravity kind of holding it down, and then you just attach to it if you want to really make it more secure.
yeah, just physical attachments, like
Cool.
basically little webbing, and we looked at a wide variety of attachments as well, and grommets and magnets. Too many vehicles are aluminum. Certainly,
Yeah,
I think all Teslas are, and then a lot of the bumpers are plastic, and
plastic and all
and
that stuff.
so
Right.
we're just looking to kind of land it via
Keep it simple.
strapping, and most of the times you're attaching to the wheel well.
Yeah. No, that makes a lot of sense. I realize we're kind of coming up on time, but I guess I am curious, just given your background, and I really do appreciate talking with all this, and especially this EV charger. I'm very excited for it. When I was really full time in the solar space about a decade ago, like it wasn't anything new, but it seemed like a lot of the breakthroughs were becoming more and more multifunction kind of cells. And sure, they were more expensive. And I guess for anyone listening, to try and make it, I'm going to try and explain something pretty complicated, I think, as easily as I can. But essentially, if a single cell, like we've kind of talked about, can maybe take anywhere from 20 to 30% of the light and convert it into electricity. The idea is you get a bunch of different types of cells that maybe one converts at 20, maybe one converts at 10, and one converts at 15. And then all together, you add those up and you get a higher efficiency or higher conversion closer to like 45 or 50%. And my camera might have died. So if you don't see me anymore, I can at least talk. But that's roughly the idea. And I always thought there's manufacturing issues with that. And it seems like they've consistently been able to kind of improve upon that. But I was curious if you've seen anything about like if or, and more generally, I guess, where you see like the future of solar cell like efficiency going. Does it really need to become more efficient? It just needs to become cheaper, or is there kind of a bit of both that you see happening?
Another awesome question, and one I've had many, many times over the years, in that I I say the efficiency is great right now at 20%. I'm blown away at how much I can get out of the surface area that I have available. And like if you have stationary applications, it's usually a non-issue. It's Energy density is a major issue in a mobile application. So heck yeah, it would help GoSun so much to have 50% efficient solar cells for the EV solar charger. Um, and where energy density and weight are really, really critical, efficiency matters. By and large, like if you're flying an aircraft or again a mobile application, but by and large, there is so much surface area on our planet that even if solar cells are, they just stop becoming more efficient. It's only going to take up like 1, maybe 2% of the available land mass on the planet to become a solar powered civilization. And again, I think that's another one of those like, wow, this is really possible. This is really viable. And then to put things into other contexts, like, like photovoltaic is around 20% efficient by and large right now. Photosynthesis, right? So a plant's ability to take sunlight and turn it into a sugar is usually far below 1% efficient. But yet, we don't get upset with plants, and we don't also say you got to grow faster. You're not fruiting yet. Um, the the available land mass is so much higher and more. The amount of solar hitting our planet is so epic that even if solar cells were 1% efficient, we really would be doing fine. It would just be more of a matter of distribution and getting that connected to the grid, to population centers, to where the energy is being utilized at a manufacturing facility or what have you. So that's kind of my, I know it's going to change and increase. The efficiency is going to increase, and certainly like on the GoSun solar ovens, our efficiency can be over 70%, but
Wow.
we're making heat instead of electricity,
Right.
right? So it's much, much lower value power. Um, but and there's like these solar. I really like solar PV and thermal, where you're making hot water as well as electricity, because you're making the electric panel is more efficient because you're stripping heat away from it, and then you're putting hot water in your tank for domestic showering and laundry and such. That's a really cool application that hasn't done super well because of the complexity of the two techs. And those are probably 40-50% efficient depending on how you're calculating it. Um, and I'm just one to not hold my breath and wait for something,
Yeah.
they're not efficient enough. Well, they're cheap as chips. Like, get over it. I'm going to wait till we figure out cold fusion. I can have a little cold fusion reactor in my backyard. Like, well, good luck. I'm going to wait till they figure out hydrogen. Like, I've heard all of this, and it's like, fine. Meanwhile, you and I are driving on sunshine, powering our households on the
Right.
sun, not paying utility bills. And yeah, we made an investment. We had to be smart. We had to figure out the right apparatus, engineering, manufacturing, you name it, and get permitted and all of that business. But we did it today versus waiting. It's like a when was the best time to plant a when's the best time to plant a tree? 10 years ago. When's the next best time to plant a tree? Today.
Right.
Like if you
Well,
can do it, like,
yeah, I mean,
yeah.
if your concern is cost, I really do struggle to believe that a fusion reactor in your backyard is going to be cheaper than solar anytime in the next 10 or 20 years. But exactly, it's just like the efficiency is already impressive. And I think what's even wilder is just how quickly the rate at which the cost has finally come down and what applications there are. It just, I completely agree with you, limitless. And it goes back to just the crazy fact how much solar energy hits the earth in a day, let alone consistently. Yeah, my apologies again. I guess the camera did die, but I'm glad you can still hear me. The one last thing, I mean, you brought up a good point, and one of the interesting things that I've seen a bit more, I don't think it's really that big of a pushback, but you've probably seen it too, is where people are saying, oh, they don't want to see solar on farmlands and stuff like that. And we both kind of know, one, that doesn't really happen. And two, there's even been examples where it's actually purposely put on farmland so you can have other crops and stuff indirectly grow with the shade, yada, yada, yada. But one of the areas that I think is even I always kind of push back. I was like, okay, let's say we don't even do that. There are so many parking lots and other just blank uh, land used for roads and everything across the U.S. What do you see? And as someone who's kind of in this space, I know traditionally there's been an issue around cost, sometimes to retroactively do it, but I just don't understand why there hasn't been more growth in putting in solar panels in parking lots and stuff like that. You have these large swaths of land that, and when you start really getting into the science of it, you see how if you're especially in a place like Phoenix, you get all the you get these heat islands more or less where you have this black asphalt that's actually increasing the temperature around it. And I'm curious. I know it's been priced traditionally, but it just seems like it's such an engineering opportunity. Steel's obviously gone up in price. Is there an opportunity, you think, in just making them out of concrete or some other kind of almost precast kind of scalable way to really kind of change that around? Because I think there's a huge opportunity for that.
Definitely. And I think that opportunity has grown. I mean, I was involved in that industry 15 years ago pretty heavily, and it was burgeoning at the time.
Yeah.
I mean, it was really taking off. I haven't paid enough attention to know the size of that, the solar carport industry, but I believe, like you look at Baja carports. I mean, I think they're doing really well out west, and they've got incredible relationships with the Home Depots and Walmarts. I know Tesla superchargers. A lot of those were happening. Yeah,
Yeah.
I
Yeah.
think I think it's basically like it's going to ultimately double the cost of the installation to go overhead so high. I think that's probably the main reason. Like, like it turns out
Interesting.
today's world of solar installs, as you probably know, I mean, it's the biggest cost is usually the racking
Yeah.
and the labor.
Which is crazy
When
because
you
like
put
10
those
years ago it
two,
was the solar and now it's crazy how much that's come down. It's racking,
trust me,
which,
yeah,
yeah.
20 years ago, it was
Yeah.
10 times solar was like the cost, and then racking
Right.
and labor were nothing compared. But it's literally inverted. The solar cells are 10-20% of the project cost. It's all in the metal and the engineering, whatever, however we're attaching, and the concrete, or you name it. And so if you can put them low, then there's going to be a lot less metal and engineering involved, because of course anything high like a flagpole is going to get hit by have a lot more moment when it gets hit in the wind. I think that's probably the major impediment. When that same corporation or even municipality has a big field, they've got 5 acres, and they can just line that up with solar instead of the parking lot. It'll be twice as expensive. Maybe that's the driver. Um, and then, yeah, you're right. Like agrovoltaics, the multi land use is really a growing thing. I know West Virginia University is doing a really interesting project right now where they put the cells on these like lower cost pole technologies. Like it's not as nice looking as you might find in a carport over a grocery parking lot or whatever. And they have cattle underneath, and the grass is
Right.
growing underneath these cells just as well, practically, because they're up like 15 feet. And so they're getting high productive grass. The cattle are very happy. They're getting some shade. They're more productive, and they're producing tons and tons of power. So, I mean, the idea that that we shouldn't use arable farmland for solar is kind of hilarious. I mean, it goes back to the cultural
Yeah.
realities, right? It's like, well, we shouldn't use arable farmland for GMO corn, or for monoculture soybeans, or whatever. Like it's just all in our perspective,
It makes a
whatever.
good headline or kind of one liner, but then when you start like actually logically looking at a lot of this stuff, it just doesn't really add up.
As if we're so efficient in our farming world that like,
Exactly.
we all care so much about every acre of soybean or corn.
Yeah.
But and I said earlier, I mean, a solar panel is probably going to be like 50 times more
Exactly.
efficient than a ear of corn, in terms of using the sun to do good for humanity.
Right.
So it's kind of hard to argue when it's 50 times more effective. It's like,
Well,
guys,
we've
where are you
tried that
coming
whole
from
corn
here?
and ethanol thing for our gas, and that didn't
Right.
work out too well for a lot of reasons. But Patrick, clearly you and I could talk about this for a long time today. I just want to say thank you for coming on and really looking forward to this. And we'll probably have to have you on again soon once the first batch of these start getting delivered, especially for the new EV charging thing. I'm really excited for mine. So thank you again for coming on, and really great to be talking about the solar industry and all the products that you guys are bringing to market.
Yeah, thanks so much for having me, Chase. We'll have to get you your EV solar charger as soon as possible this summer, and we'll look forward to being back someday in the future.
That's a wrap on this episode of Grid Connections. A huge thank you to Patrick Sherwin from GoSun for sharing his inspiring journey from launching on Kickstarter with a solar oven to paving the way for off-grid solar-powered EV charging. If this conversation got you fired up about solar's potential, or if you're just excited about living cleaner and driving on sunshine, there's never been a better time to jump in. We've got plenty more fascinating guests and breakthrough renewable energy stories coming your way. If you enjoyed this episode, share it with at least one friend, colleague, or fellow clean tech enthusiast. Spreading the word helps us shine a brighter spotlight on innovators like Patrick. And while you're at it, please do us a favor and leave a positive review on our podcast page. Your feedback makes all the difference in helping others discover grid connections and the exciting world of sustainable energy solutions and clean transportation. Until next week, this is the Grid Connections Podcast, signing off.